Question 10 reads, what is the combined capacitance of the capacitors shown in the figure above? So in this figure, in order to solve for the overall capacitance, we need to first solve for these two parallel capacitors here and find and combine these two. And then once we can combine these two parallel capacitors, then we'll have three capacitors in series, which we can use a different equation for to solve for the overall. So what we're going to focus on first, like I said, is the parallel capacitors. So we have in parallel capacitance, to find the total, all you have to do is add up the two capacitances. So we're going to add up 6. We're going to add up 6 microfarads plus C2 says that it is 42.8. So 42.8 is equal to 48.8 microfarads. So instead of these two parallel capacitors, we can imagine that we only have one capacitor now that is equal to 48.8 microfarads in magnitude. And so now we have three capacitors that are in series, and for C1 it says we have 48.8 microfarads as well. So basically this is as simple as just using the capacitors in series formula. I'm sorry, this should have been 48.8. And so in order to solve for the overall capacitance of three capacitors in series, the equation that we're going to use is 1 over capacitance total is equal to 1 over 48.8 plus 1 over 48.8 again, and then 1 over 48.8. And then so when we add these together, we get 1 over CT is equal to 0.06. And so now we can't forget to take the inverse of this value in order to get the inverse of this and just find the capacitance total. So the capacitance total is going to be the inverse of this value here, and so that will be 16.3 microfarads, which is B.